One of the important topics in geometry is that of similarity, similar polygons, similar figures. What are similar figures? How can you tell when two figures are similar? What are the characteristics of similar figures or similar polygons? A polygon is simply a many-sided figure. It can be as few as 3 sides and upwards. And when we talk about similar polygons, what we're talking about are polygons are figures that have the same shape but different sizes. For example, the two triangles there on the right. These are definitely different sizes, but they have a similar shape. And when you have two similar polygons, there are two things that are always true. First of all, corresponding angles are congruent. And by corresponding, we mean angles are parts of figures that have the same position in their respective figures. For example, the two angles that are highlighted in purple are corresponding angles because they're in the same position within their own triangle. The same can be said for the two green highlighted angles and the two orange highlighted angles. But what we say about corresponding angles, that they are congruent, cannot be said about corresponding sides. But corresponding sides in similar figures are proportional. What that means is that we can write the lengths of corresponding sides as ratios, and the ratios will all be equal, therefore proportional. Let's look at some examples. Here we have two triangles that are said to be similar. The little symbol there highlighted in yellow is similar to. So we are being told by that symbol that triangle ABC and triangle XYZ are similar triangles. And because they are similar, then we can say some things are true about the angles and the sides. Number one, we could say that angle A is congruent to angle X because they are corresponding angles. So they're congruent because they're corresponding. We can also say about side or segment BC that it corresponds to segment YZ, and therefore we can write them as a ratio. Angle B is congruent to angle Y, and side AB is corresponds to side XY and can be written as a ratio. And finally, angle C corresponds and therefore is congruent to angle Z, and side CA corresponds to side ZX and can be written as a ratio. Let's look at another example, but this time it's not they are not triangles, but they are quadrilaterals. And notice the arcs that are drawn within each angle. They tell us that the corresponding angles are congruent. Where there is only one arc, then those two angles are congruent. Where there are two arcs, then those two angles are congruent, and so forth. And so because these are similar polygons, we can say some things about the angles. Number one, angle A is congruent to angle E. Angle B is congruent to angle F. Angle C is congruent to angle G. And finally, angle D is congruent to angle H, all because they are similar figures and those pairs of angles are corresponding. We can also say this about the sides, that side AB can be written as a ratio with side EF. The same can be said for sides BC and FG, sides CD and GH, and side DA and side HE. Now we can also determine similarity or facts about the similar figures even though we don't have a drawing or a diagram of the figures. Notice example 3 says if triangle LMN is similar to triangle RST, we're asked to find what must be true. Well, first of all, about the angles, we can say that angle L is congruent to angle R. Notice well where L, the letter L, and the letter R lie in their respective names. L and R fall at the first place of the list of letters, therefore they correspond, and therefore they are congruent. Notice angle M and angle S are in the same position. The letters themselves are in the same position, and also N and T. So angle M is congruent to angle S, angle N is congruent to angle T, because the letters represent the angles of the triangle. Now, what about the sides? Well, notice that LM and RS are right next to one another in their respective names. There are segments that would lie between those 2 points on those triangles. And so side LM and side RS correspond to one another and can be written as a ratio. The same can be said for sides MN and ST. And finally, LN and RT. The letters that name the angles are in the same positions in the names of the triangles, and therefore their segments are corresponding. Now notice that there is another vocabulary term that we're being introduced to. It says a very important term to know when talking about similar polygons is the word included. An angle is said to be included between 2 sides, and a side is said to be included between 2 angles. Now, what does that mean in particular? Well, let's look at what that means with this pentagon ABCDE. We're asked to use the polygon to answer the questions, and the first question is, which angle is included between segment AB and segment BC? There's segment AB and segment BC, and notice the angle that is between those 2 segments is the angle B. So angle B is said to be the included angle between AB and BC. Well, which side is included between angle E and angle D? Well, notice there's angle E highlighted in orange and angle D highlighted in orange, and the segment that lies between those 2 angles we say is included between is the segment ED. And finally, which angle is included between segment AE and segment AB? Well, we see that angle A lies between those two segments. So we say that angle A is included between AE and AB. But I want you to notice something. Even in the listing of these letters, of these sides and angles, using just the letters, notice what letter is common in segment AB and segment BC. It's the letter B. So that clues us into which angle is included between AB and BC. It's the angle B. And the same can be said for the angle A, since A is the common letter in the name of segment AE and segment AB. Therefore, the angle A is the included angle. But then notice that angle E and angle D has the segment ED between them. So we see a pattern even in the naming of these segments and angles that clue us into which ones are included angles and which one are included sides. So looking at this triangle AMC, we can name the angle that's included between AM and MC. It's angle M. And we can name the side that is included between angle A and angle M. It is the side AM. And finally, we can name the side that is included between angle A and angle C, and it is the side AC. Now you have received enough information to complete the assignment 8-2.